Hi everybody, 4,000 Holes in Blackburn, Lancashire. A lyric from the Beatles song A Day in the Life, song whose lyrics were mostly taken from stories that John Lennon was reading in a newspaper. And it got me thinking, the poor highways maintenance chap from Blackburn Council that will have had to deal with 4,000 holes probably had absolutely no clue where to start with that. It was an enviably large task. 4,000 sounds like a lot of potholes, and I realised it was very similar to the job of your average vulnerability manager out there who has a huge number of vulnerabilities to fix and no idea where to start them. This is going to be a very quick, very dull, very boring talk on a very quick, very dull, boring subject. There will be a longer version of this talk at some point. Just a warning, these slides are for people that can actually pay attention to things. There's no fancy graphics, there's no clever memes or bad dad jokes in the middle of them. It's very dull and boring. So let's start by talking about how most vulnerability management programs start. You come along, somebody realizes you need to do vulnerability management in your organization. So you go out, you buy Qualys, Nessus, Nexpose, any other vulnerability scanners. There's lots out there. The big ones are all quite similar. And what you get back is you fire it first at a huge number of devices. You get an absolute pile of data back. You get a colossal number of vulnerabilities right across your organization that need fixing. And at this point, one of two things happen. Either you become security policemen, you put your hat on, you go around with your big stick, and you sort of moan at the people that own these systems and write this software, and tell them, they should be taking your security seriously, and they should fix all the things. You become universally hated, and you're seen as a blocker that just stops people doing real work. A lot of organizations go down that route, and that's probably the worst kind of vulnerability management position to be in, where the entire company hates you. The other way of dealing with this that a lot of companies take is they get their big report, they put some nice shiny headers on it, they drop it on a boss's table, and they run like hell. Nobody wants to be the guy to actually implement the fixes. So it's like, I've done my bit, I've told you where all your vulnerabilities are. Well, let's get out of Dodge before somebody makes this my problem. But the third option of this really is we start prioritizing. We look at our big list of vulnerabilities, and we try and find a way of prioritizing the important ones. So how do we do that? Well, normally people's first attempt is they look at their vulnerability management scanning tool and realize it has a thing in there to allow you to assign priorities and risks to subnets or to bits of your network or things like that. And people generally start off using those, but they realize pretty quickly that their complex network with a million different things in a million different places doesn't really fit the very simple zones or categories or whatever that the software has. So other places, they go for the quick wins. They realize it's a numbers game. They've got a big lot of vulnerabilities. So given the choice of fixing one single CVSS 10 unauthorized RCE over here, or 20 CVSS 2s down here for some weak crypto that is, you need to be physically manning the middle of the box to get hold of, they're going to go for the 20 because that gets rid of 20 vulnerabilities, makes their numbers look a lot better. That gets rid of the one, doesn't make them look any better at all, really. However, in terms of actual getting your company popped, that RCE is the one that's going to get you popped, not the weak crypto down there. So that's not really an ideal way of doing it either. Some just prioritize by CVSS score. It's like, okay, we're going to take the raw scores that these vulnerability products chuck out the back of it, and we'll do the high numbers first and do the low numbers last. And whilst I'm normally a big apologist for CVSS, CVSS is very much maligned and is actually good for comparing huge amounts of data. So, this audit to another audit, or, this year's to last year's, or things like that. It's dreadful for comparing individual vulnerabilities. It can be made a lot better by using the environmental features of CVSS. There is actually a scoring system in there so that you can go and say, for this vulnerability, there are these mitigations in place. The environmental stuff in there is quite usable, but it puts you back in the same position as the first problem here. If you spend your life not actually finding vulnerabilities, but of actually feeding the vulnerability system data to classify your vulnerabilities, and that's every bit as boring as finding them. So, so neither of those I do. We need to move to some sort of risk-based system. So, what do we want to do if we do a risk-based system? Well, we want to prioritize them based on the risk of exploitation. Going back to our earlier example, we want people to focus on that unauthorized RCE over that is going to get owned, and not so much on the low stuff, which is, there's a theoretical risk there, but there are so many other stars that need to align, it's not likely to happen. The trouble to make risk decisions is you need data to make those risk decisions on. And we've just highlighted the problem that we're actually trying to fix here is we've already got too much data with the vulnerability data. Just going, hey, we've got a big pile of data. To fix this big pile of data, what we need is an even bigger pile of data. Not a great place to be starting from. And even if you already have this data, in a lot of cases, this data isn't all in one place. You may well have something like a CMDB, and for those that don't know, Configuration Management Database is what it stands for in ITIL terms. In a lot of other non-ITIL organizations, it's just a risk register. But essentially, when I use CMDB, what I really mean is list of all your hardware assets and other data about them. CMDB is actually a much wider scoping thing, but that's what we mean in this case. As I say, you may well have these, but in the old XKCD cartoon goes, when if somebody realizes we have 3 different policies for something, what they'll do is they'll look and go, we should amalgamate those all into one policy. And what you don't end up with then is one policy. What you actually get is 4 policy. Exactly the same as CMDBs. If you've got several different CMDBs or asset lists containing different bits of information about your hosts and your networks and things like that, normally running out and trying to build a new CMDB will just get you another CMDB that's half-arsed and only does half a job. So what the crux of this talk is really about is how to build that CMDB so that it gets adopted and becomes your one source of truth. I also remember these are grown-up slides. If you don't know the XKCD cartoon I'm looking for, go Google it, go find it yourself. You're not going to get pretty pictures in this talk. So, let's start from CMDB. One thing to bear in mind, you have something your company probably needs. You own a list of all the hosts on your network. If you've done discovery right, you've got a full list of everything on your network. That is very valuable data to a lot of places in the organization. A lot of places need to know what PCs have we got. You've got that list. That's a good starting point. What you really need to do is find a project that needs that data and hijack it. Now, I kind of hinted at this on Twitter the other day, and so I said, you can't say that, Glen. People get the wrong idea. You don't want, you've got that data, you want to share it, you want to get it out there. You don't want to hold it up for a ransom for other people's stuff. So we're not going to hijack it. We're going to work together on a mutually beneficial solution, or hijack it if you have to. But yeah, essentially, we're going to buddy up with somebody else that needs that data and let them be the driving force behind building your CMDB. So our first CMDB project isn't actually going to be CMDB. It's going to be something else that just happens to be sat on top of our CMDB. So what sort of data do we want to put in there? We'll say we've got our list of hosts and our list of vulnerabilities. What else do we need in there to be able to make risk decisions around that data? So first of all, we don't want to reinvent the wheel. We don't want to be the owner of all this data. We want to try and grab other people's data and get it into or close to our CMDB so we can use it. We don't want to actually start owning a lot of this data. But we can reach out to lots of other teams to see how their data is stored and see if it would be better stored in a CMDB. You'll be amazed how much of our organization works on big lists in Excel where once a year they may come along and pull in your list of hosts and compare it to what they've paid for or what the network teams think they've got or what the licensing team thinks they've got. The trick is to reach out to those teams and say, hey, we've actually got all this data over here in this lovely CMDB that we've built. Why don't you take your data and put it in the same place, and then we can use the same reporting layer, the same management tools, have the same people look after it, and try and get them to work with you to put their stuff that they've currently got holding little spreadsheets together. They'll probably get a much better result out of it. They'll probably get bits of people to own the process, maybe own the database it runs on, or own the management layer. And generally, your CMDB starts to grow into time over an actual useful thing that everybody bolts on top of. And point out to them that at the moment they're taking your data, say annually, they can have it in real time. If your vulnerability management software is updating your list of hosts all the time, so could theirs, so that their GDPR map or whatever they're doing also has this data going in there live. So you can basically. You're helping them to make their thing better by building on top of your thing. So what sort of data do we want in there? Things like network type, network segments, that sort of thing. If you do well segmented networks, then make that a factor. The idea with here, what we're basically our starting point is a host on our public perimeter containing very private data is the highest risk. On top of that, we're adding mitigations. We're adding things that lower the risk. So network segment, if it's on a network segment that you can only get to if you're in a special group of users and use 2FA, that's the mitigation. We can add that into our list. Host type, sort of a vending machine may be is a whole different risk to an access control system. So build that into there. Reach out to people like your compliance team. They have loads of information about the data that you've got on service and how important it is to the company and how much risk there is to the company. So for things like PCI, it's like, if it's within the cardholder data environment, the CDE, that's a very high risk. If it's not, it's less of a risk. Same with GDPR. If it's got PII on it, it's quite a high risk. If it hasn't, then it's quite a low risk. Reach out to all these teams, get their data back, put it with your data so you can use their data to help drive your prioritization. Similarly, the actual financial value is of relevance. Big, important server system, high risk. Little desktop, probably not so much risk. Some odd ones that we've used that have worked quite well, data recovery priority. If something's got a 15-minute SLA in a DR situation, that's probably quite important to the company. We probably care about that a lot, make that patch. If we've got something that's got a 3-week SLA that's holding the lunch ordering system, probably not going to be top of our patching list either. Change status was another one that we tied into. If something needs, that an engineer can just go and change without approval, that's quite a low risk system. That's probably not particularly one that is top of our list to care about. If it's one that needs 3 layers of quite senior approval, again, that's probably a high risk, high value system. So you can build that into it. Things like SLAs, OLAs, there's all sorts of things we can put into it. And I say it's all about mitigation. So, if you've got a list of things that are behind the WAF and the things that aren't, the things behind the WAF naturally lower that risk. Therefore, we can give a little bit of time on the patching. And literally anything that helps us decide the importance and of the relevance of the data on there. And the longer version of this talk, I talk a lot about SEC architecture and how it can save you. Everything SEC architecture do is a mitigation. Everything that your prioritization should be doing is taking into account any mitigations and giving people longer patching SLA based on the number of mitigations there is. So go talk to your architects, talk about what they've done, try and codify that, try and build that into your calculations as well. So the end result, what have we got? We no longer have a patch all the things attitude. We've got a patch the most important things first attitude, which is great because you can actually say to people, well, look, we don't ever, patching isn't a zero-sum game. We don't expect to patch everything. We just want the important stuff, and this is the important stuff. The SLA between what's important and how long it can be fixed, that can be a moving line depending on the capabilities. Make it easy at first. Say, okay, anything that's a 10, we're going to give you 7 days to fix. Anything that, and then it's a case of actually 10s are really important, so we're going to fix those under incident conditions. And similarly, anything that's a high, we're going to give you, a month, and then cut it down to, say, okay, can you do this within 10 days? Okay, let's move that side that one. And because you've got the maths there, it gets really flexible to where to put that line. It also cuts down a lot on arguments. The only real argument it has is whether or not all the mitigations that they're saying is the reason that they shouldn't be bothered patching. Does the math take that into consideration? If they're saying, well, nobody can ever get to that machine, it's like, well, we've taken that into account. No, that machine is there's no data on that machine, so why do we care? That's taken into consideration. So it actually cuts out a lot of the arguments about why people should and shouldn't patch. So some final tips to help it to land. Metrics reporting. Again, longer version, I talk a lot about reporting, and that reporting is really important, but reporting is a narrative. You're trying to send across a message. That message should be how well improvements are going. It's not about how bad your infra team and your ops team and your devs are about patching. It's all about how they're improving. So control that narrative. Highlight the good behavior. Don't necessarily highlight the bad too much. Big numbers are scary. T-shirt sizes are great. So very much aim for critical, high, moderate, low, rather than a 6.3 versus a 4.4. And percentage changes are great. The thing you're trying to show is that everybody is improving this and getting better. So a 10% change sounds a lot better than something going from 1,000 to 900. So lots of percentage change numbers in there. My slides have stopped working. Focus only on what's attainable. If you're only expecting people at the moment to focus on criticals and highs, don't bother reporting on the moderates and lows, or bury that deep in the report so that nobody really cares about it. You're trying to change behaviour with this, and if you think that this is behaviour you're not going to change in the moment, don't bother actually reporting on it. Again, when people see that huge pile of vulnerabilities, it looks bad. If you can say, hey, we've cut out 80% of our criticals and highs, that's a good message to get across. Help people understand that risk owning is their job. Too many places it's like, oh well, this machine's hard to patch, so we've asked security for an exception. It's like, that's not an acceptable thing. The risk is there. Security can advise on risk. Explain to them that this is their risk, it's their choice. Whether they patch it is up to them or not. And this report is to help them understand that risk. One of the things that we did that worked really well was letting them set their own SLAs. We sort of jokingly said, it's like, okay, moderate vulnerability, you can have a year to fix that, and they all sort of scoffed as if to say, that's stupid. Why would we have a vulnerability open for a year? It's like, okay, that is stupid. We agree, but what's acceptable? What do you think is a sensible timescale to fix this in? And then once you've got that in place, you measure it and say, okay, well, we're hitting that quite easily. Can we get it faster? Do you need more automation if we're missing it? Let them, there's no point in creating a target they can never hit. And another one, again, just like reporting in general, another one I go into a lot more in the longer version of this is someone back and say, oh, we can't afford the downtime to take that. That box makes us money. We can't afford the downtime just to patch it for something unimportant. The argument against that is that at the moment you had a vulnerability management problem. You've now got a vulnerability management problem and an availability problem. What happens if that box goes down for something unplanned? Get them to fix the availability problem. If the problem is you can't patch it because it can't go down, the problem is that it can't go down, not that it can't be patched. That's just a symptom. And some bonus slides for red teamers at the end, just because I said in the abstract to include something for red teamers. If you can get hold of the CMDB data, if you can get hold of the reports around it, it points to a lot of the dead bodies. So things to look out for in that data. Look for things that are flagged as out of scope. These are the dark corners. These are a bit that nobody really wants to be bothered at looking after. And if the people that are trying to drive vulnerability management aren't looking after it, there will be bad stuff in them. Legacy stuff that's old, stuff that is classed as too hard to patch because it's ancient. Again, if it's old and it's not getting patched, it's vulnerable generally. Look for stuff that's risk accepted. As I mentioned before, I despise risk acceptance as a concept. The risk is always there. You can't accept a risk. It just means you just have decided there are other factors that mean that you can't meet an SLA. But anything that's risk accepted, again, there's a reason that's not getting patched. Go and dig into it because it's definitely bad. One of my favourites, the unknown and unloved. In any organisation, stuff gets built that nobody ever, the team that built it got disbanded and sent 6 races to the wind, which means that nobody's looking after it, nobody's patching it. If you've got a CMDB that implies ownership, go and find out the stuff with no owner, because that's the stuff that isn't getting looked after. And that, ladies and gentlemen, at just under 20 minutes, is my guided tour of how to win at building a CMDB to actually do vulnerability management properly. If any of you have any questions, you've got literally 30 seconds. Come and find me online, Glen Pegden on Twitter or most things, or come and grab me if you're actually here at the conference, or if not, find me online. Thanks a lot. Goodbye.